All right, hello there. We're going to talk about limits today, the first day of our calculus topics. So here we go with limits day one. So on these slides, I have some graphs on here, and that's all. So you can just draw yourself a little quick graph when I do these. You don't have to be all perfect or anything like that. So let's see, limits, day one. So we have 2 days of this. But anyway, so in math, a limit has a definition like this. It is the value that a function approaches as the input, the x value, approaches some value. All right, so the way that we write it is we write this. We write LIM, and so I usually write it in cursive, but anyway, LIM, and then x goes to, and that's the value that you're saying x is approaching. And then what you do is you put your function right here. So sometimes you'll see f of x if there's not an equation, but I'm going to use the equation 2x plus 1. And I'm going to say as x approaches 2. So my function that I'm using is y equals 2x plus 1. So I'm going to draw that on the graph over here. So just draw yourself like a quick sketch, really. So I start at 1, go up 2 over 1. So just your basic line. All right, so I'm trying to look and see on this graph as x is going towards 2. So as my x value is coming in towards 2 from either side, what is the y value doing? Well, you can kind of see that, oh, it's going to 5. So this is a nice quick and easy one. The answer to this question is just 5, but let me show you why a little bit more. All right, so let's say you have somebody coming in towards that spot. So we're all talking about this spot like right here. We're coming in towards that spot from either side. All right, so we're gonna have Mr. What's his name? Butterfly over here, have Mrs. Ladybug here. She's coming along from the right and she's going to there. And he's coming along from the left and he's following the line and he gets to the same place. So they both get to the same place and the place they get is 5. So what I want you to remember, so it's nothing really complicated, is that the limit, another way to think of it is to think of it as the intended height of the function. Now, that word intended is going to be kind of like important on the next page. All right. Okay, so draw yourself another picture here. So draw yourself a picture, and the point 4, -2 is going to be like a hole. After that, it's gonna curve up here, and then before it, I'm gonna say it kind of like comes down and goes back up. I don't really care about that much, but I just need that 4, -2 to be a hole. So kind of sketch that. So this time, this is f of x. I don't have an equation for it. I don't really need one. We're just gonna do a lot of things with pictures today so you get the general feel of like what a limit is. So I'm gonna ask you this question. The limit as x goes to 4 of f of x. Okay. All right. So now you might be thinking like, oh, like there's a hole there. So remember, I'm not asking you this. I'm not asking you for f of 4. If I asked you what's the function value at 4 right now, you'd be like, oh, it does not exist. So DNE means does not exist. There is no answer for f of 4 right now. Okay. And we'll talk about that more a little later also. But the limit, remember the limit is the intended height. So if Mrs. Ladybug comes along and she's going along, she's like la 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 la, and she's going towards that spot. She's like, oh, I think this curve is going to -2. And then Mr. Butterfly comes along and he's coming from the other way and he's thinking, oh, this looks like it's going to -2. It's okay that the curve is not there when you get there, but it's where it was intending to go. For all intents and purposes, you think like, oh, I should be going, when I'm at 4, I should be at -2. So that's why the answer to this is -2. Okay? All right, now let me move those guys out of the way. So there might be another little thing that gets done to you here, and that is, let's say somebody on this graph, they have this graph. Remember piecewise functions, they go like this. They say f of x equals, they give you a little bracket, and then usually you write something here and write something there, and it says, oh, if x is, greater than 4, do this, and so forth, all like that. All right, so what if one of the definitions in this graph put a point here at 4, -3? So this is your graph you're looking at. So now this would no longer be true. If somebody asks you for f of 4 right now, you'd be like, oh, it's -3. But I still want you to realize that the limit is still -2. Because remember, these guys coming in from the left and right, they don't know that they don't need to know, they think this graph is going to -2. And this guy over here, she thinks the graph is going to -2. All right? It doesn't matter that the graph actually exists right here. It matters as you follow the curve, what were you going to go to on the left and the right? What were you going to go to? Okay? All right. So let's do one more picture with these guys. That's a little bit trickier. And so in this one right here, draw yourself a picture at -1, 2. There's a dot right there. And then just draw yourself, I don't know, like a line coming down. Okay? And then at -1, 4, there is an open hole there, and then like a parabola kind of like comes across and goes like the one side of a parabola. So this is my f of x. Okay, so this one, if I asked you some random question here, like what's the function's value at -1? So if you go to -1, there's a couple things going on here, but f of -1, like we've learned earlier in the year, is right there. It's that one with that filled in dot. So f of -1, the answer to that question, and that's just the function's value at -1, would be 2. Now, so that's not even talking about the limit, so let's talk about the limit now. So what would the limit be as x goes to -1 of my function that I have pictured? All right, so let's look at these guys up here. So ladybug, he's coming along, butterfly, he's coming along, and he's going along from the left, and he's like, oh, here I am, I got to 2, that's where I was supposed to go. And then ladybug comes along, and she's like, la la la, and she's going around, she's like, oh, wait a minute, I'm all the way up here at 4. And so she's in a different place. And so that's a big no-no. When one side goes to one height and the other side goes to another height, you have a mismatch. All right, so if this happens to you, you have to say that the limit does not exist. Okay, so that's supposed to be an E right there. Whoops. All right, now somebody could also further ask you some more questions about this that will have answers. All right, so let's check this. If I asked you the limit as x goes to -1, and I put a little negative sign after that, like in the top corner. When somebody puts a negative sign right there, they mean from the left. So it's almost like you're not supposed to look at the right side of -1 at all. So like this whole side of the graph, like you don't even look at it really, okay? So if I go from from the left, I would just say to you, oops, I need my little f of x there. I would only be looking at the left side, and I would say to you, oh, hey, it's basically what the butterfly saw. And so the butterfly saw, oh, la, 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 I'm going to 2. So you could answer 2. And then if somebody asks you the limit as x goes to -1 from the right, so that little plus sign there means from the right, it's like you have blinders on and you can't even see the left side, you're just coming in from the right. Okay, so it's basically whatever the ladybug's doing. So you're like, oh, she's coming around and stopping at 4. Okay, so if somebody asks you that, you could say 4. So these left and right limits have answers, but do you notice they don't agree? And so when you don't agree from the right and the left, this is what happens to your main limit right there. Okay, all right, so let's take a step back from looking at pictures for a second, and let's just look at actual functions. So when you have an actual function, you might be given an easy one like this. Let's say you have the limit as x goes to 1, and this is your function, 5x to the third minus 2. So if you think about it, 5x to the third minus 2, that's a cubic function, and it's moved down 2. It has a stretch of 5, so maybe, it kind of looks like that or something like that. All right, so you think about it, okay, as I go to 1, maybe about here, that's whatever that is the answer. Well, you can also just do this. If you are able to just plug 1 into here and get an answer, then that's your answer. Just like we could have done that on the line at the very beginning also. All right, so if I plug 1 into there, 5, 1 to the third minus 2. And the reason I can do that is because there's no holes, no asymptotes. This is just like a generic like polynomial function. So I know it's continuous. So I just plug in the number and I get 3. So I knew that earlier because this point right here is 1, 3. Okay, so sometimes it's just like quick and easy like that. Other times you have some issues. So let's say, for example, the last one on this page here, let's say I was doing this, the limit as x goes to 3 of this function, 2x squared minus 6x over x minus 3, okay? And you notice I can't plug 3 in here because I get a 0 on the bottom, and in fact I get a 0 on the top also when I plug 3 into there. So I would get 0 over 0, which is indeterminate. You don't know what the heck that is. So you can see over here I have this little table right there. I'm going to show you how to make that in Desmos in a minute, or you can do it in your calculator. But I have my function here and I have my x values. So what you can do, and sometimes MathSpace will ask you to do this, is you can start entering numbers closer and closer to the number you're trying to get to. So you see it's undefined there, but remember we're going for the intended height. So as I approach 3 from things, just a little bit under 3, I rise up and I kind of get to this number as I come from the right of 3. So from the right of 3, if I start at 3.1 and then go back towards 3, getting closer and closer to it, so basically it's kind of like this, 3 is right here. We're getting closer from the right and closer from the left to 3, and you see I get to this answer. Well, so you can kind of see that what was happening is I was probably approaching a height of 6, but I couldn't really get there because I can't actually plug in 3. So it is possible to get an answer when there is nothing there. This is exactly like this graph back here where you had a hole and there was no answer there, but you can still have a limit. So the answer to this is 6. Okay, so let me show you on Desmos how you would go and do that. So you have your function 2x squared minus 6x minus 3. All right, so where is my Desmos? There it is. So what you do, and I'm just going to basically get rid of this one. You go ahead and put in your problem. So you put y equals, oh crap. What is it doing? All right, I'm just use my finger. So y equals, and then put in your problem. So I'm going to do 2 divided by, so it makes a fraction. Then I'm going to go back up. So let's see, I have 2x squared minus 6x, and then on the bottom x minus 3. All right, so there's a graph, and I'm going to click over on the right, and if you after you click on the right, you hit the settings wheel, see a little table. So choose a table, and there it puts it into a table for you. But you don't want these numbers, so you put in the numbers that you want. So I wanted 2.9, press enter, and then it gives me those answers, then 2.99, enter. And so you can see what I was doing on that, how I got that table on the other page. All right, so then you can kind of like guess the answer in a way, kind of take an average of the last 2 answers that you get. All right, so another trick you can do here, and this doesn't always work, but did you notice that you can factor that? In the numerator, if you take out a 2x, that leaves you with x minus 3. The denominator, you take out and just leave x minus 3, these cancel. So what you really have is the limit as x goes to 3 of that function 2x. And you can see, oh, I plug in 2 or 3, 2 times 3 is 6. So that's another way to get it if the problem's factorable. All right, so just another few little graphs here we're almost done here. And so my next graph is going to look like this. I'm going to have an asymptote at 3. So draw yourself a graph. I'm going to put a vertical asymptote right here. And then we're going to draw a function. I don't know, it comes in from the left, kind of along -2 and goes up. So it's just your basic rational functions. This one comes in from the right and goes off to the side there. Okay. All right, so let's look at a couple things. Let's look at the limit as x goes to 3 from the right of my function. And you don't know what the equation is, you don't have to. Okay, so from the right. So remember, I'm just coming from the right. So when I come in from the right, that's coming in this way, I come along my function and it starts to go down. All right, so my answer to this would be -infinity. Okay, and I know it, limits are like your height and infinity is not really defined, but if you can answer it like that, you should say -infinity or +infinity. All right, so now we're going to do the reverse side. Limit as x goes to 3 from the left. All right, so as I come in from the left, look at that, it goes all the way up to +infinity. Okay, so those are possible and you have answers, but if somebody asks you this, the limit as x goes to 3, just plain old 3, not from the left or the right, f of x, notice this, these two, they disagree. So you can make a case for two different answers, so that means that your whole limit does not exist. Okay. All right, now on the other hand, if we had a different picture that looked like this, let's say you still had your asymptote at 3, but in your picture, your graph went up to infinity there, and the left side looked the same and went up that way as well. So this time, as you come from the left, it's going up to +infinity. From the right is +infinity. Okay, so if somebody asked you to do the whole limit here, so the limit as x goes to just 3, like totally 3 of your function, you would just say infinity, okay, because it does agree, so you can answer. All right, so then I have one last little one. Oh, I need to graph a little bit, but not really. So let me ask you this. It's kind of basic, but you might not realize it unless I kind of show you. So x goes to 5, and let's say I just have like a function in here and it's just 2, okay? So it might seem a little bit strange to you, but remember, this piece right here, this is the equation. I'm giving you an equation, a y equals equation, so that's y equals 2. So if you go over here and draw the graph of y equals 2, you're like, oh, that's just a horizontal line. So it doesn't matter where I am, the answer is always 2. If you approach anywhere from the right or the left, you're always going to be at a level of 2. So it's really easy when you have a constant right here, like anytime you have a constant right here in this spot, the limit of a constant is literally always that number, okay? So that's like a nice easy rule to know. So if you had like, oh, what's the limit as x goes to 100 of -4? Well, the answer would be -4 because you're always going to be -4. There's no changing that. Okay. All right, and that's it.